Hello, in this lecture we find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two smaller circles. We know that the radius of this circle is equal to B, the radius of this circle equals to A, and our mission is to find out the ratio between the two radii, that is to say the ratio between the radius of this circle that is B over the ratio of the radius of this circle that is A, or in other words, to find out the ratio of B over A. In addition, we know that AN equals to NC, and also triangle ABC is a right triangle that is partially located inside the biggest circle. This angle equals to 90 degrees. Side AB equals to 5 units in its length, side BC equals to 12 units in its length, and then side line segment AN equals to NC. Our mission is to find out the ratio of B over A. So first of all, we'll implement the Pythagoras theorem on the right triangle ABC. So according to the Pythagoras theorem, here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. Again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in total we found out that AC squared equals to 25 plus 144, that is actually 169. Found out that AC squared equals to 169. Here we take a root out of this equation, and finally we found out that AC, the hypotenuse AC equals to the square root of 169 is 13. The length of the hypotenuse AC is 13 units. So here, this hypotenuse AC of the right triangle ABC equals to 13 units in its length, and because of the fact that AN equals to NC, it means that at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So we can write down that AC over 2, it is actually 13 over 2. So the first half is AN and the second half is NC. Okay, so found out that AN equals to NC equals to 13 over 2. That is to say, each half of the hypotenuse is equal to 13 over 2 units in its length. So here, the second half is NC, that is 13 over 2 units. So we can write here that NC equals to 13 over 2 units. In the next step, I will present to you new rule number 8, and we'll implement rule number 8 in our drawing. Should remember that this triangle ABC blocks the circle that is radius is A. So here we have, in relation to this issue, we have the rule number 8 that talks about a right triangle that blocks a circle. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. So here we have the right triangle ABC. This angle ABC equals to 90 degrees. Side AB equals to A units in itself. Side BC equals to B units in itself. And finally the length of the hypotenuse AC is C. And the radius of this circle is equal to R. According to rule number 8, you can find out the radius of this circle that is blocked by the right triangle ABC only by knowing the side lengths of the right triangle ABC that blocks the circle. That is to say, the radius R will be equal to A plus B minus C over 2. So the radius of a circle that is blocked by a right triangle will be equal to the addition of the two perpendiculars to each other minus the length of the hypotenuse over 2. Okay, so we can actually implement rule number 8 in our drawing. Because in our drawing we have the right triangle ABC that blocks the circle that its radius is A. According to rule number 8, the radius A will be equal to AB plus BC, AB plus BC minus AC over 2. Repeat again. According to rule number 8, the value of the radius A will be equal to AB plus BC minus AC over 2. So we know that AB equals to 5 units in length, BC equals to 12 units in length, and we just right now found out that the length of the hypotenuse AC is 13, so it is minus 13 over 2. So we find out that the radius of this circle A will be equal to 5 plus 12, that is 17, minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. So we're going to find out that the length of the hypotenuse A equals to 2 units. Here the radius of this the small circle A equals to 2 units. In the next step we define the center of this circle as P. We define the center of this circle as Q. Finally we define the center of the bigger circle, this point, as O. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. So point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of this circle that is equal to A, and A equals to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, we define the point of tendency of tangent BC with this circle as N, and we will join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. So the radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So inside quadrilateral TPBN we have 1, 2, 3 right angles. This also equals to 90 degrees. So we have here 3 right angles. The sum of right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle. In total, they must be equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles in this quadrilateral TPBN to 360 degrees, the missing angle here must be equal to 90 degrees. So in quadrilateral TBPN, we have 4 right angles. Any quadrilateral that has 4 right angles must be its right angle if not a square. So we relate to quadrilateral TPBN. It's a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to 2b. But Pn is 2, therefore Tb must be also equal to 2. Likewise, Tp must be also equal to Bn. But Tp is 2, therefore Bn must be also equal to 2. So if we found out that quadrilateral TPBN is not a rectangle, but a square, because all of its sides are equal to each other. So, according to what is given us in the question, BA equals to 5. TB equals to 2. So AB minus TB is 80. Again, AB minus 8. AB minus TB is 80. AB is 5. TB is 2. So 5 minus 2 is 3. So 80 equals to 3. And then we have rule number 2, that the lengths of 2 tangents from a common external point to a circle are equal. For the common external point A, we have 2 tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they are equal to each other. That is to say, AM equals to AT equals to AM, but AT is 3, therefore AM must be also equal to 3 units in its length. We have already found out that AN is 1/2 of the hypotenuse AC, that is to say it is equal to 13 over 2. AM equals to 3, therefore AN minus AM equals to MN. Again, AN minus MA equals to MN. So I write it down. AN minus AM equals to MN. Okay, again. It is very easy to say from the drawing that AN minus AM equals to MN. AN is 13 over 2. Minus AM is 3. And it is equal to MN. Here we take two as a common factor from those two expressions, that is to say we multiply minus 3 by 2 and then we divide by 2 and we get that 13 over 2 and minus 3 times 2 is minus 6, that equals to MN. 13 minus 6 is 7 and 7 over 2, so MN equals to 7 over 2 units in its length. This 97 MN, it is equals to 7 over 2 units. In the next step, I present to you a new rule and we will implement the new rule in our drawing. This will be rule number 7. According to rule number 7, if the line segment that is drawn from the center of a circle bisects the chord, then the line segment is also perpendicular to the chord. Here the center of this circle is 0.0. From the center of the circle, we draw line segment OM that is bisect chord AB. That is to say, we know that AM equals to MB. And therefore, line segment OM will be also perpendicular to chord AB. That is to say, this angle will be equal to 90 degrees and this angle will be equal to 90 degrees according to this rule number 7. So, whenever a chord that is drawn from the center of a circle bisects a chord, then that chord will be perpendicular. Then that line segment will be also perpendicular to the chord. Here, OM bisects chord AB, that is to say AM equals to MB. Therefore, OM will be also perpendicular to AB. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to this rule number 7. So we can actually implement rule number 7 in our drawing. Point O is the center of the bigger circle. We join points O and N together by a straight line. Line segment ON bisect chord AC. Why? Because AN equals to NC. Therefore, according to rule number 7, line segment ON will be also perpendicular to AC. So if ON is perpendicular to AC, it means that this angle will be equal to 90 degrees. This angle will be also equal to 90 degrees. So we can find out that ON is perpendicular to tangent AC. Point Q is the center of the circle. Point N is the point of the circle itself. Therefore, QN will be the radius of the circle, of course. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we can write down here that QN, the radius QN is also perpendicular to the radius AC. The radius QN is also perpendicular to tangent AC. And from those two equations, ON is perpendicular to AC and QN is also perpendicular to AC. We derive that point O must lie on the radius UN. And again, this is point O, that is the center of the bigger circle. This point O must lie on this radius QN of this circle. Why? Because of the fact that ON is perpendicular at point N to AC and QN is also perpendicular at point N to AC. It means that if point O doesn't lie on QN, then it will never create angle of 90 degrees with AC. For example, if point O is located here and we join points O and N, here, it will never be equal to 90 degrees. This angle will be less than 90 degrees and the other angle will be more than 90 degrees. So, point O must lie on QN in order that both ON also and also QN will be perpendicular to AC. Or QON is one straight line. If point O lies on QN, then the QON is one straight line. QON is one straight line. QON is one straight line. In the next step, we'll define the touching point of this circle with the biggest circle. This point is U. We draw tangent VW at point. Tangent VW that we go will be perpendicular to both circles at point U. So this is tangent VW. As you can see from drawing, the tangent also to the biggest circle, and it is tangent also to this circle at point U. So here point Q is the center of the circle, point U is the point of the circle itself, therefore QU is the radius of this circle that is drawn to point U, that is to say it is drawn to the point of tendency of tangent VW with this circle, and whenever you have a radius that is drawn to the point of tendency, tangent VW will be perpendicular to the radius QO. So can I know that QU is perpendicular to VW? QU, the radius QU is perpendicular to tangent VW. Likewise, if you focus on point O, is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. So can I down that OU is also perpendicular to VW. The radius OU is also perpendicular to tangent VW. And from those two equations, QU is perpendicular to VW and OU is perpendicular to VW. QU is perpendicular to VW and OU is also perpendicular to VW. We derive that all those 3 points, O, Q, and U, must be located on the same straight line. Okay, O, Q, U is located on one straight line. Points O, Q, and U, they are all located. I said QU is located on is one straight line. Repeat again. This line segment OQU is one straight line. Okay, so found out that OQU is one straight line. OQU is one straight line, and QON is one straight line. So both those two line segments, QON and OQU, has 2 points that are common. It belongs to both of them, O and Q. Okay, and we know that with 2 points we determine a straight line. Because of the fact that in both line segments, in both the straight line QO and we have OQ, and in OQU we also have the 2 points OQ. It means that 2 points determine one straight line. Therefore, it must be one straight line. N or QU is one straight line. Both Q or N has those 2 points on Q, and or QU also has the same 2 points on Q. And because of the fact that with 2 points we determine a straight line, we get that this N or QU is one straight line. N or QU is one straight line, or NQ or NQU is one straight line. Okay, NQU is one straight line. NQU is one straight line. Good again. OQU and QON has 2 points that are common to both of them, O and Q. And with 2 points we determine a straight line. Therefore, in total we can say that NOQU is one straight line. Therefore, NQU is one straight line also. NQU is one straight line. If NQ is one straight line, then NU is also a straight line. NU is a straight line. And if NU is a straight line, NU is a straight line that touches the circled points N and U. And therefore, NU is a chord that passes for point Q. That is the center of the circle, and we know that any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. Okay. NU or UN is the same, is the diameter of the circle. We also know that the diameter of a circle is twice as long as the radius, and the radius of this circle is b, therefore the diameter UN must be equal to 2b. Therefore UN equals to 2b. Okay. So in the next step we will join points O and P together by a straight line. Point O is the center of the bigger circle, point P is the center of this smaller circle. The smallest circle touches the biggest circle at this point. This is their touching point. We define their touching point as point S. In the next step, I present to you your rule number 9, and we will implement rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, that is to say they have an internal launch between them, like here, they touch each other internally, then the straight line that connects their centers together, the center of the circle, the big circle is point O, the center of the small circle is point M, and the straight line that connects their centers together is the straight line OM. This straight line OM must pass for their touching point. The touching point is here at point P. That is to say, if OM must pass for point P, it means that OMP is one straight line. Okay, so OMP is one straight line. We can actually implement rule number 9 in our drawing. Again, the straight line that connects the center of the big circle with the center of the small circle is the straight line OP, according to rule number 9, because of the fact that the smallest circle touches the biggest circle at point S, they have an internal arch between them. Therefore, the straight line OP that connects their centers together must pass through their touching point, that is to say for point S. That is to say OPS is one straight line. According to rule number 9, then segment OPS is one straight line. If OPS is one straight line, it means that OS also is a straight line. Again, OS is a straight line. So, but before that, we know that OPS is a straight line, therefore we get that SO minus SP equals to PO. Again, SO minus SP equals to PO. Write it down. SO minus SP equals to PO. What is the definition of line segment SO? OS or SO, it is the same. It starts from point O, that is the center of the biggest circle, and S at point S, that is the point on the biggest circle itself. This is exactly the definition of a radius. And we define the radius of the biggest circle as X. Therefore SO is X, so you can substitute SO by X. Minus SP. Point P is the center of the circle, point A is the point of the circle itself. Therefore, PS is the radius of this circle that is equal to 2 units. So we can substitute PS, this equation, by 2. In conclusion, we found out that PO equals to X minus 2 units in its length. Here, this line segment PO equals to X minus 2 units in its length. In the next step, we'll extend the perpendicular ON by a straight line. ON is a perpendicular, it is absolutely a straight line. When you extend a straight line by a straight line, the result must be a straight line. So this line segment is a straight line. So if we focus on this side of this straight line at point N, here the sum of the areas must be equal to 180 degrees, according to the rule that the sum of the areas from one side of a straight line is equal to 180 degrees. So which angles we have this side of the straight line at point N? We have this angle plus the missing angle. This angle is equal to 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. Okay. We know that AC is tangent to the small circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of this circle, point M is the point of the circle itself. Therefore, PM is the radius of this circle, that is equal to 2 units. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. So if AC is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we'll draw perpendicular on the radius MP at point P. Again, we'll go perpendicular on the radius MP at point P exactly. So here, actually, this angle equals to 90 degrees according to our construction. We'll extend the perpendicular until it touches the other perpendicular, until they touch each other. And we'll define the touching point as point T. In this way, we created quadrilateral MNPT. Inside quadrilateral MNPT, we have 1, 2, 3 rectangles. Therefore, the fourth angle must be also equal to 90 degrees. So actually, in quadrilateral MNPT, we have 4 rectangles. Any quadrilateral that has 4 rectangles must be at least a rectangle, if not a square. So we relate to quadrilateral MNPT as a square, and we know that the opposite, any quadrilateral that has 4 rectangles must be at least a rectangle, if not a square. So we relate to quadrilateral MNPT as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, in rectangle MNTP, MN must be equal to PT. MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. We define the length of line segment ON as H. In the next step, I will copy the right green triangle OTP in the new page, and we implement to this right green triangle the Pythagoras theorem. The triangle OTP. We already found out that the hypotenuse PO equals to x minus 2. Right here. We just right now found out that PT equals to 7 over 2. And what is the length of OT? From the moment it's very easy to see that OT equals to ON plus NT. Again, OT equals to ON plus NT. ON is H and NT is 2. So in total, OT equals to H plus 2. So you can write here that OT equals to H plus 2. Now we will implement on this right triangle of PT the Pythagoras theorem. According to the Pythagoras theorem, PO squared equals to OT squared plus PT squared. Again, PO squared plus PT squared plus OT squared, or PO squared equals to OT squared plus PT squared. So PO is x minus 2, therefore PO squared is x minus 2 squared. And it is equals to OT squared. OT is h plus 2, therefore OT squared is h plus 2 squared. Plus PT squared. PT is 7 over 2, therefore PT squared is 7 over 2 squared, that is 49 over 4. Conclusion, found out that x minus 2 squared equals to h plus 2 squared plus 49 over 4. Here we'll open the brackets on both sides of the equation, and we get that x minus 2 squared equals to x squared plus 2 squared, that is 4, minus 4x, and is equal to h plus 2 squared. H plus 2 squared is h squared plus 2 squared, that is 4, plus 4h, plus 49 over 4. Okay. In the next step, we'll join points O and C together by a straight line. What is the definition of the straight line OC? The straight line OC starts from point O, that is the center of the biggest circle, and ends at point C, that is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of the circle, that is equal to x units according to our definition. ON is also, according to our definition, equals to h. And in the beginning of the lecture, we found out that NC equals to 13 over 2. This again equals to 90 degrees according to rule number 7. Now, I'll copy the right triangle ONC in a new page, and we will implement on this right triangle the Pythagoras theorem. Okay. Repeat again, NC equals to 13 over 2, ON equals to h according to our definition, and the hypotenuse also, the radius OC of the biggest circle equals to x, also according to our definition. So, this is the right triangle ONC that I copied from the original drawing. Here by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ONC, we get that OC squared equals to ON squared plus NC squared. OC is x, therefore C squared is x squared. That is equal to ON squared. ON is h, therefore ON squared is h squared plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared. That is 169 over 4. In conclusion, we found out that x squared equals to h squared plus 169 over 4. Now we can substitute x squared in this equation by h squared plus 169 over 4. We'll do it now, and we get that here x squared so x squared is h squared plus 169 over 4 plus 4 minus 4x, and it is equals to h squared plus 4 plus 4h plus 49 over 4. So here we have h squared on both sides of the equation. So h squared will get cancelled, and we also have 4 on both sides of the equation, so 4 also will get cancelled. And we left only here in this side of the equation, we left only 169 over 4 minus 4x, that is equals to 4h plus 49 over 4. Here we subtract 49 over 4 from this equation, and you get that 169 minus 49 over 4 minus 4x equals to 4h. Here we add 4x to this equation and we will get that 169 minus 49 it is 120. In total this equation will be equal to expression will be equal to 120 over 4 and it is equal to 4x plus 4h. We added 4x to this equation. Here we take 4 as a ground factor for those two expressions, so inside the brackets we will have x plus h. 120 over 4 is 30. So in conclusion, found out that 30 equals to 4 times x plus h. We'll divide this equation by 2. And we get that 30 over 2 is 15. 4 over 2 is 2, so 15 equals to 2 times x plus h. Here we will divide this equation by 2. And finally we will get that x plus h equals to 15 over 2. Write it down, x plus h equals to 15 over 2. And again, found out that x plus h equals to 15 over 2. What is the length of line segment UN? From the moment it is very easy to see that UN equals to UO, that is the radius of the biggest circle, that is equal to x, plus ON, that is h. So in total we get that UN equals to x plus h. X is the radius of the biggest circle plus h, that is NO. So UN equals to x plus h. I know that UN, from one side UN, just right now found out that UN equals to x plus h. But from the other side, we have already found out that UN found out that UN equals to b, that is to say it is the diameter of the circle. UN equals to b, you can write here that UN equals to 2b. And from those two equations, we will derive that x plus h equals to 2b. But we already found out that x plus h it is also equals to 15 over 2. So we can write here that x plus h equals to 15 over 2. And for this equation, 15 over 2 equals to x plus h equals to 2b. We will derive that 15 over 2 equals to 2b. We divide this equation by 2 and finally we get that b equals to 15 over 2 over 2 is 15 over 4. So we found out that b, the radius of this circle b equals to 15 over 4 units in its length. And we already found out that the radius of this circle a equals to 2 units. A equals to 2 units. So b, the ratio of b over a will be equal to b, that is 15 over 4, over a, that is 2. 15 over 4 over 2 is 15 over 8. So finally we found out that the ratio of b over a, the ratio of b over 8 is equals to either 15 over 8. In terms of numbers, it is equals to 1.875 without units. So repeat again. The answer to this question is the ratio of b over a is equal to either 15 over 8, or in terms of numbers, it is equal to 1.875 units. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found the ratio of b over a, that is to say, the ratio between the radius of this circle, that is b, to the radius of this circle, that is a, or the ratio of b over a. We know that we have in the drawing the biggest circle. Inside the biggest circle we have two smaller circles. In addition, we have the right triangle ABC that is partially located in the biggest circle. And we know that AN equals to NC, AB equals to 5 units, BC equals to 12 units. Our mission is to find out the ratio of B over A. First of all, we focus on the right triangle ABC. ABC is the right triangle because this angle ABC is 90 degrees. We implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem on the right triangle ABC, AC squared equals to AB squared plus BC squared. I'll repeat again. The right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in conclusion, we found out that AC squared equals to 25 plus 144. 25 plus 144 is 169. So in conclusion, we found out that AC squared equals to 169. We took out all of these equations and we found out that AC equals to the square root of 169 is 13. AC equals to 13. So the hypotenuse of the right triangle ABC, AC equals to 13 units in its length. And because of the fact that AN equals to NC, it means that at point N, the hypotenuse is bisected into two halves. The first half will be AN and the second half will be NC. Again, AC over 2 is 13 over 2. It is equal to the first half, that is AN, and it also equals to the second half, that is also NC. That is to say, here NC, AN equals to NC equals to 13 over 2. So here, this line segment NC, this is the second half, this is equal to 13 over 2, it is half of the hypotenuse. Then I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal R equals to A plus B minus C over 2. So here we have the right triangle ABC, and angle ABC equals to 90 degrees. The left of side AB is A units, side BC equals to B units in left, and finally the hypotenuse AC equals to C units in left. The right triangle ABC blocks the circle, the radius of the circle is R. According to rule number 8, we can calculate the radius. We know the value of the radius only by knowing the side lengths of the right triangle that blocks the circle. That is to say, it will be equal to, the radius will be equal to A plus B minus C over 2. We can implement number 8 in our drawing. In our drawing, here we have the right triangle ABC blocks the circle. The radius of this circle is A. According to rule number 8, you get that the value of A will be equal to AB plus BC minus AC over 2. Okay. A equals to AB plus BC minus AC over 2. AB is 5, BC is 12, and AC is 13. So in total, AB plus BC minus AC is 5 plus 12 is 17, and 17 minus 13 is 4. And 4 over 2 is 2. So if we will find out that the radius of this circle A will be equal to 2 units. In the next step, we define the point of tendency of tangent AB with the circle as T, and then we join points T in the P together by a straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle. And we have the radius PT, that is 1 to point T, that is the point of tendency of tangent AB with the circle. Whenever we have a radius that is 1 to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals 90 degrees and this angle also equals to 90 degrees. Okay. Likewise, we have define the point of tendency of tangent BC with this circle sine. We join points P and N together by a straight line. Pn is the radius of the circle that is equal to 2, and the radius Pn is 1 to point N, that is the point of tendency of tangent BC with this circle. Whenever we have a radius that is 1 to the point of tendency, then tangent BC will be perpendicular to the radius NP. That is to say, this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. So inside quadrilateral T, B, and P, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in the quadrilateral is equal to 360 degrees. So quadrilateral PTBN has 4 right angles, and any quadrilateral that has 4 right angles must be tested a rectangle, if not a square. So we relate to quadrilateral TB and P as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to TB, but Pn is 2, therefore TB must be also equal to 2. Likewise, TP equals to Bn, but TP is 2, therefore Bn must be also equal to 2. So we found out that quadrilateral PBN is not a rectangle but a square, because all of its sides are equal to each other. Okay. Then I presented to you rule number 8 and implemented rule number 7, but before that, here we know that AB or BA equals to 5 units, BT equals to 2 units, therefore BA minus BT is 80. BA is 5, BT is 2, so 5 minus 2 is 3, so 80 equals to 3. And according to rule number 2, that the lengths of two tangents from common start point to a circle are equal, we get that from the common start point A, we have two tangents to the circle, tangent AT and tangent AM. According to rule number 2, they are also equal to each other. That is to say, AM, AT equals to AM. But AT is 3, therefore AM must be also equal to 3. Okay. Then found the length of side MN. Actually, AN equals to 13 over 2, it is 1/2 of the hypotenuse C. AM equals to 3, therefore AN minus AM equals to MN. Again, AN minus AM equals to MN. Repeat again. AN minus AM equals to MN. AN is 13 over 3, minus AM is 3, is equal to MN. 13 over 2 minus 3. Here we make a common factor of 2 by multiplying minus 3 over 2 and divided by 2. This is the common factor here. So minus 3 times 2 is minus 6, so we have 13 minus 6 over 2. It will be actually equals to MN. 13 minus 6 is 7, so in total MN equals to 7 over 2. Okay. Then presented to you rule number 7 and implemented rule number 7 in our drawing. Moving to rule number 7. If a line segment that is drawn from the center of a circle bisects the chord, then the line segment is perpendicular to the chord. The center of the circle is at point O. From the center of the circle we draw line segment OM that bisects chord AB. That is to say AM equals to MB. Only to rule number 7. Line segment OM will be also, if we bisect the chord, line segment OM bisect the chord, then line segment OM will be also perpendicular to AB. That is to say this angle will be equal to 90 degrees and this angle will also equal to 90 degrees. Okay? So whenever a line segment that is drawn from the center of the circle bisects the chord, then the line segment will be also perpendicular to the chord. So we can implement rule number 7 in our drawing. In our drawing, we join points O and N together by a straight line. Point O is the center of the bigger circle. So from the center of the bigger circle we have line segment ON that bisects chord AC, that is to say AN equals to NC. Therefore, according to rule number 7, AN must be also perpendicular to AC. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay. So we can write down that ON is perpendicular to tangent AC. ON is perpendicular to tangent AC. In the next step, so we found out that ON is perpendicular to AC. Here point Q in the center of the circle, point N is the point of the circle itself, therefore Qn is the radius of this circle. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever a radius is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. Or Qn is perpendicular to AC. So in either that also Qn is also perpendicular to AC. And from those two statements that ON is perpendicular to AC and Qn is also perpendicular to AC, we derive that point O must be located on the radius Qn. This point O, that is the center of the bigger circle, must be located on the radius Qn. Why? Otherwise, if point O is not located on QN, it will never create 90 degrees at point O with AC. If point O is the radius QN, it means that QON is one straight line. Line segment QON is one straight line. That is from one side. Here we define the touching point between this circle and the bigger circle as U. At point U they are touching each other. They are touching each other. Then we draw tangent VW, the tangent to both circles, to the small circle and to the bigger circle. So here, point Q is the center of the circle. Point U is the point on the circle itself, therefore QU is the radius of this circle. So the radius QU is drawn to point U, that is the point of tendency of tangent VW in this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. You can write down that QU, radius QU is perpendicular to tangent VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle, and we have the radius OU that is drawn to point U, that is to say it is drawn to point U, that is the point of tendency of tangent VW in the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. So you can write down that the radius OU is also perpendicular to VW. Again, the radius of the biggest circle OU is also perpendicular to VW, and the radius of this circle, that is QU, is also perpendicular to tangent VW. And from those two statements, we derive that in total, QOU is one straight line. OQU is one straight line. All the 3 points OQ and U, they are all located on the same straight line. OQU is one straight line. Okay, why? Because if, for example, point Q is not located on OU, it will not create angle of 90 degrees with VW. Or even if point U is not located on UO, then this, if point O is here, then this angle will never be perpendicular to VW. That is to say, all the 3 points, O, Q, and U, are located on the same straight line. In order that both O, U will be perpendicular to VW and Q, U will be perpendicular to VW, all the 3 points Q, O, Q, and U must be located on the same straight line. So we can find out that OQU is one straight line. So I found out that OQU is one straight line and QUO is one straight line. So between those two line segments QON and OQU, we have two common points. O and Q, they are common points to both lines, to those two line segments QON and OQU. And we know that 2 points determine one straight line. There are 2 points that are coming, therefore they must be on the same straight line, because those 2 points determine one straight line. Therefore we can say that in total N, O, Q, U, all 4 points, they are all located on the same straight line. Which straight line? The straight line OQ, because OQ, there are 2 points that are coming to line segment QON and to line segment OQU. And because of the fact that 2 points determine one straight line, QU determine OQ determine one straight line, therefore all the 4 points N, Q, N, O, Q, and U, they are all located on the same straight line. Okay, so if N, O, Q, U are all located on the same straight line, it means that NQU is also located on the same straight line, and therefore NU is also located in the same straight line. So NU is one straight line, NU is one straight line, but it touches the circle at point N and U. So actually NU is a chord that passes for point Q, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore NU or UN is the diameter of the circle. Okay, you can write down here that NU is the diameter of the circle. Again, NU is the diameter of the circle. And the diameter of the circle, any circle is twice as long as the radius. The radius is b, therefore the diameter NU or UN must be equal to 2b. Okay, then I presented to you rule number 9 and implemented rule number 9 in our drawing. According to rule number 9, if 2 circles touch each other internally, then the straight line that connects their centers together must pass through their touching point. The center of the big circle is here, point O. The center of this small circle is point M. The straight line that connects their centers together is the straight line OM, and the straight line OM must pass through point P according to rule number 9. That is to say, OMP is one straight line. OMP is one straight line. So we can implement rule number 9 in our drawing. Here we join points O and P together by straight line. Point O is the center of the bigger circle. Point P is the center of the smaller circle. Point S, the smallest circle touches the biggest circle. They have a point of tendency here. So according to rule number 9, the straight line that connects their centers together is OP. OP must pass for point S. That is to say, OPS is one straight line. Again, according to rule number 9, OPS is one straight line. If OPS is one straight line, OPS is one straight line. It means that SO minus SP equals to PO. Again, SO minus SP equals to PO. SO minus SP equals to PO. What is the definition of OS? OS, point O is the center of the bigger circle, point S is the point of the circle itself, therefore OS is the radius of the bigger circle that is equal to X. So we can substitute OS by X. And what is the definition of SP? Point P is the center of the smaller circle, point S is the point of the smaller circle itself, therefore PS is the radius of the smaller circle that is equal to 2. So we can substitute SP by 2. Okay. If we will found out that PO equals to X minus 2, then, so this line segment PO equals to X minus 2, then we extended the perpendicular ON by straight line, and when we extend the straight line by straight line, the result is a straight line. So here we have a straight line. If we focus on this side of the straight line, the sum of the angles must be equal to 180 degrees. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees. We know that AC is perpendicular to the circle at point M. Point M is the point of tendency. We joined points P and M together by straight line. Point P is the point of the center. point P is the center of this circle, point M is the point of the circle itself, therefore PM is the radius of this circle, that is equal to 2. The radius PM is drawn to point M, this is the point of tangent AC with this circle, and therefore AC will be perpendicular to the radius MP. That is to say, this angle equals 90 degrees and this angle equals 90 degrees. Then we did the construction. We draw perpendicular on the radius MP at point P. So this angle equals 90 degrees according to our construction. And we extended the perpendicular until those two straight lines touch each other at point T. So inside quadrilateral MNPT we have 1, 2, 3 degrees, therefore this fourth angle must be equal to 90 degrees. Therefore we relate to quadrilateral MNPT that is 4 right angles is a rectangle. And we know that the opposite sides of rectangle are equal to each other. That is to say MP equals to NT, but MP is 2, therefore NT must be equal to 2. Likewise in rectangle MNPT, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. And then we defined line segment and OSH, and I copied the right triangle of PT, the right rectangle of PT in the equation. We implement on it the Pythagoras theorem. The hypotenuse PO is x minus 2. We just right now found out that PT equals to 7 over 2, and what is the length of TO? TO equals to ON plus NT. That is to say, OT equals to ON, that is 8, plus NT, that is 2. So in total, OT equals to H plus 2. OT equals to H plus 2. And now we implemented the Pythagoras theorem on the right triangle POT. According to the Pythagoras theorem, PO square equals to OT square plus PT square. Again, PO square equals to OT square plus PT square. Okay, so PO is x minus 2, therefore PO square is x minus 2 square, and it is equals to OT square. OT is h plus 2, therefore OT square is h plus 2 square, plus PT square. P is 7 over 2, therefore PT square is 7 over 2 squared, it is 49 over 4. So in conclusion, we found out that x minus 2 square equals to h plus 2 square plus 49 over 4. We open the brackets on both sides of the equation. We found out that x minus 2 square equals to x square plus 2 square, that is 4 minus 4x, and it is equals to h plus 2 square. H plus 2 square equals to h square plus 2 square, that is 4, plus 4h, plus 49 over 4. Then we join points O and C together by a straight line. Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. Therefore, OC is the radius of the biggest circle, that is equal to x. ON equals to h according to our definition, and NC equals to 13 over 2. This angle equals to 90 degrees according to rule number 7. So I copied the right angle ONC, and we implemented on this right triangle ONC the Pythagoras theorem. According to the Pythagoras theorem, the right triangle ONC, OC square equals to ON square plus NC square. OC is x, therefore OC square is x square, and it is equals to ON square. ON is h, therefore ON square is h square, plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square, that is 169 over 4. So in conclusion, we found out that x square plus 2h, x square plus 2h square plus 169 over 4. Therefore, we can substitute x square in this equation by h square plus 169 over 4. We did it, and we got that x square is h square plus 169 over 4 plus 4 minus 4x. That is equal to x square plus 4 plus 4h plus 49 over 4. Then we have h square on both sides of the equation, so h square will get cancelled. We have 4 on both sides of the equation, so 4 will also get cancelled. So in this side of the equation, we have to leave 169 over 4 minus 4x. In the other side of the equation, we have to leave 4h plus 49 over 4. Then we subtracted 49 over 4 from this equation, and found out that 169 minus 49 over 4 minus 4x equals to 4h. We added 4x to this equation and found out that 169 minus 49 is 120 over 4. and it is equals to 4x plus 4h. Then we took 4 as a common factor of this out of these two expressions, so inside the brackets we have only x plus h. 120 over 4 is 30, so in conclusion found out that 30 equals to 4 times x plus h. We divided this equation by 2 and finally found out that 30 over 2 is 15 and 4 over 2 is 2, so in conclusion found out that 15 equals to 2 times x plus 2. We divided this equation by 2 and finally found out that x plus 2 equals x plus h equals to 15 over 2. Repeat again, x plus h equals to 15 over 2. But what is the length of this 9 segment un? Un equals to uo plus on. That is to say, un equals to uo, that is x, plus on, that is h. So in total, un equals to x plus h, un equals to x plus h from one side, but from the other side, we have already found out that un equals to 2b, it is the diameter of the circle. So can I write here that un equals to 2b, and from those two equations, un equals to x plus h and un equals to 2b, we will derive that x plus h equals to 2b. X plus h equals to 2b. But x plus h, it is also equals to 15 over 2. So can I write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we derive that 15 over 2 equals to 2b. We divided this equation by b and finally found out that b equals to 15 over 2 over 2, that is 15 over 4. So b equals, regardless of the second, b equals to 15 over 4. A equals to 2 units, and b over a will be equal to b, that is 15 over 4 over 8, that is 2. So 15 over 4 over 2 is 15 over 8. So in conclusion found out that b over a equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 units. I repeat again, the ratio b over a equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 units. Okay, thank you very much.